Hi, hello, welcome back to my channel. This is day 2 of learning Java in 30 days. In this day 2, we are going to learn about data types and variables, the basic building blocks of any Java program. Before going to day 2, we can recap Hello World. In day 1, we wrote our first program Hello World. We compiled and saw the output. But you might be wondering what actually happened under the hood. When we write Java code, it's not directly understood by the computer. Then how? It's because of the JDK. Whenever we run Java code, remember the JDK compiles it. The JRE provides the environment and the JVM makes it talk to our computer. That's the magic that turns our words into working programs. But what is JDK, JVM, and JRE? We must understand the difference between JDK, JRE, and JVM before proceeding further to Java. JDK, Java Development Kit, JRE, Java Runtime Environment, JVM, Java Virtual Machine. At first, JVM. JVM is virtual machine that runs Java bytecode. It means convert bytecode to machine code, zeros and ones, for your OS. We know Java is platform independent, but JVM is platform dependent, different for Windows, Macs, Linux. But bytecode is platform independent. Don't confuse. Java program language is like platform independent, but the JVM is dependent because bytecode is platform independent, right? When it converting into machine code, it becomes platform dependent. Based on the OS, the machine code will be different. To be clear, think of JVM like a translator that takes Java's universal language bytecode and speaks your computer native language. Computer native language, Macs is different, Linux is different, Windows is different. What is JRE then? Java Runtime Environment. JR is everything you need to run Java programs. JVM is like the engine that converts bytecode into machine code and runs it. Java core libraries and classes. In these JRE, we all have JVM and Java core libraries and classes. Like what are libraries like collections, IO, networking, math, etc. JVM alone can't do everything. It needs these libraries to run. With JRE, you can execute Java programs, but you can't write or compile them because it does not include a compiler. Okay? Like JVM is actually the engine of a car, does the actual work of running JVM, like it will run. JRE like the whole car, engine plus fuel plus essential parts that leads to actually drive. So you can drive, but you can't build a new car. Like you can run the programs, but you can't write a new program. So to write, to convert, and to run, all these kit are like we can say Java Development Kit. Java Development Kit (JDK) is a full package to develop plus run Java programs, which contains JRE, which already has JVM plus libraries, development tools, compiler, Java C, debugger, Java doc, etc. Java C compiler turns .java written code into .class bytecode. JDB debugger to test and fix codes. Java doc documentation generator for front-end developers or to know the APIs how it works. So JDK is for developers coding and compiling and running. So overall relationship is like JVM is the engine runs bytecode. JR is like the car engine plus parts can drive run programs. JDK is the garage workshop with car plus tools you can build, repair and drive. So we can represent the relationship as like JDK is equal to JRE plus development tools or JRE is like JVM plus libraries. Interview shortcuts you can say JVM executes bytecode, JRE runs Java programs, JDK develops plus runs Java program. I hope you got the clarity about JDK. What next? Data types. You know Java is statistically typed programming language, which means variable types are known at the compile time. At the time of compilation, it checks all the fields. what are the types, which data is assigned. But what is data type? What kind of data a variable can store and how much memory it needs. What kind of data and how much memory. Hmm. But why data types matter in Java? Data types matter in Java because of memory efficiency, performance, code clarity. Choosing the right type, byte versus int, saves memory. Proper type reduces time errors. In runtime, it reduces errors. Explicit typing makes code more readable to make it clean. Okay. The data types are classified into two types, primitive and non-primitive. Primitive data types are the basic built-in types in a programming language. They store simple values and not objects. And non-primitive data type are complex types. They are stored by reference, not by value. Primitive data types think of them as a raw building blocks. They hold the actual value, not the reference. Like size is fixed, does not change across usage. I mean, wherever you use, the size will be same and the value will be same. And where it is stored in the stack memory, retrieval will be fast. Okay, let's see example of primitive data type. Primitive data types: bytes, 100, short, int, long, float, double, char, boolean. Let's try to compile. Byte value 100, short 3000, int, long value. You can see one byte, short 2 bytes, int 4 bytes. Okay, you might thinking what are these bytes, right? Let's see. What is a bit? First, bit is like binary digit. Smallest unit of data in computing can only be 0 and 1. What is a byte? Like 1 byte is equal to 8 bits. Like it's a group of 8 binary places, slots that can be present data. Okay, in this 1 byte, there are 8 places. 8 places you can accommodate. 0, 1, 0, 1, 0, 1 in that place. So that much value it can store. So for unsigned versus signed, there are formulas. So how much range they can store in that value. So we can see formula is like minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Here you can see 1 byte equal to 8 bits, right? 8 bits. 2 power 8 minus 1 of minus 1, right? 27. Here up to 8 bits is like 128 to 127 it can store. Let's change this value. 127. 127. If we increase to 128, we got there. At the first only I said, right, statistically type. So it compiles. While compiling only it will check what data type is assigned, how much the value is assigned. It is possibly lossy conversion, like the data 128 is exceeding its storing capability. Remaining storage capacity you can find with the same formula. Next we learn non-primitive data types: strings, arrays, class, objects, interfaces. Okay. Next we learn non-primitive data types: strings, arrays, class, objects, interfaces. Strings, a sequence of characters. In Java, strings is a class, not primitive, but behaves like a special type, immutable. Once created, you can't change it. You need to append it to new string, but you can't change it. And the arrays are like a collection of elements of the same type stored in continuous memory. Fixed size, once declared, cannot grow or shrink. We can't increase the size or we can't reduce the size in the runtime. Class is like a blueprint for creating objects, define properties and behaviors. Properties is like variables, behavior is like methods. And object, a real world entity, creates from a class. It holds actual values for the class properties. Can use it methods. Interfaces, we will check in, present now it is not needed. We will check in the upcoming classes. Let's see the examples. First, string. Okay, string, data type, and name and John. You can see name John, string 1, string 2, these are the references, and this one is a comparison. I will say about this. Here string name equal to John. These strings are stored in the string pool, special memory area. If the same literal already exists in the pool, Java reuses it. Like we will reuse it, not creating a new one, because to save the memory and memory management will be clear. To know the same it is used or not, see string str1 Java, str2 Java. Identify the hash code. Both the hash code are same only because for these two names it is pointing to the same Java. But if we create the same one, S3 and S4 in the object one, new keyword, this is object, new keyword use. Okay, new, same we can check here for the reference. See, same Java are saving str3, str4. It is stored in the heap. Every time in the heap, a new memory is allocated to this field str3 because it will consider as a new field only. This one, this one. What is the difference between these equal to and equals? Here it will check for the reference. Here it will check for the content. Here it can comparison for the content. It will use content is same or not. Here it checks for the reference. Total reference is same or not. That's why here we got true and false true because the reference is not same but the content is same. Second one is arrays. Second one is arrays. Okay. Array example 20. See, arrays fixed size, like it can't grow or shrink during. Here the number and this length is 3 only, 0 1 2. We can check by 1 2 3. Length is 3. We can't increase or we can't decrease. We can access only in between this length. So in code, if the length is 3, we can access up to 3 minus 1 up to 2, like 0 1 2. We can initialize in three ways. The first way is to declare statistically, like directly we can initialize like int array is equal to how many we want. This one is static way, or else we can initialize in a dynamic way. Like first we need to give the type of size, how many we want, 5. Okay, the length will be 5, and then we can assign the numbers 0, 0th index, first index, second index, third index, fourth index. And the third way is to combination initialize. First initialize, then directly you can declare array value. Next we have class. Class is like a blueprint, as we discussed. It defines properties and behaviors. The properties are color, brand, and year. We can write the methods, but we can learn in upcoming classes. So every time we need to create one blueprint, we can execute that and we can see. Okay, next one is object. Object is a real world entity created from a class. Here class, we created one car, like one blueprint for it to create a car. Then we can make it on a real world by creating some object, car Honda. So you have a car blueprint, you created a Honda car. Then you can create Tesla car. So this blueprint helps to create cars, real world entities, forms an object. Like here you are creating with the blueprint Honda car and the Tesla car. These are the non-primitive data types. I hope you got some clarity. For clear example, we can go with like class is like a recipe, object is like a cake made from recipe. Like we have the instructions and the output is a cake. Okay, string is like a sentence or words. Array is a box filled with fixed slots. Like while booking any movie, we have some fixed slots, right? Seats. We can't grow or reduce the seats. The seats are fixed. Until now we completed data types. We need to learn variables. Data type. So variables. Why variables? Why? You know the data types are like the alphabets in English. Then variables are like words. We form using those alphabets, and when we put these words together, we get the sentences, right? In English, if we combine data types and variables, we can write actual programs. Variables. So what is variable? A variable is like a container box in the memory that stores a value. Until now we are discussed about the types, like which type, what to store, and a variable is a container box to store the memory value, the actual value to store in memory. Variable is like name, speed. We need one name. And the what is the data type? Int. What the value we need to store? 50 is the variable. Variables are classified into three types: local variables, instance variable, static variables. Local variables is like specific to that specific function. Instance are like up to creating that instance variable. Static is like it will we can access in all over the methods. Let's see the example. Local variable. Declare inside a method, constructor or a block. Created when the method is called. Destroyed when the method ends. Must be initialized before it use. So here you can see inside a method. This is a method or a constructor, or this is one specific block, right? x10, y20. After this block, if we try to access this y, what will happen? You see, cannot find symbol because the local variable is specific to this block only, not outside the block. The outside the block, it is ended. When the method is created, it is called and destroyed when the method ends. Here starting it is created and the closing one, the method ends and it is destroyed. So we can't access this one. Second, instance. Instance variable is like declare inside a class but outside any method. Each object gets its own copy. So this one variable, every object have its own copy like this brand and year, lifetime, as long as the object exists. Okay, see, the same variable brand and year we use it for the Honda car and the Toyota car because each object gets its own copy. As long as the object is existed, we can access the brand and year to respective its object. Let's go to static variable. Declare it with the static keyword shared by all objects for the class. Only one copy exists in the memory, no matter how many objects are created. How many objects you created? Only one exists, like university, right? So in university, so many students are there, their name changes, but the university name will be same. Here you can see before creating the objects, we can use the university name. We created John. How many objects you create? Like one object, two objects, so many. So static variables are like this. Thank you all, and please share your thoughts. Please give your feedback, what to improve, like in PPT redesigning or any new way you want to learn. And please comment how your understanding is it better, how can I improve. Thank you so much. Subscribe, share, comment. Lazy Tech Learner.